Questions on any of the assignments before we get started? Questions on any of the homework assignments? We good with homework questions? Yes? Okay. Now, unfortunately, fortunately, depending on how you look at it, we're going to skip 4-4 for now. I was planning on having us do 4-1 or 4-4, parts 1 and 2. But just time-wise, I want to get to 4-5, 4-6 and make sure we have enough time to cover those and get y'all ready for the test. And if we do have time for 4-4, we will come back to it. Now, the main things with 4-4 is it's going over factoring. That's the main topic for 4.4. And most of the factoring that we'll be doing, we can do it without the specifics of 4.4 because it's going over sum and difference of perfect cubes and grouping. Now, one of the big things that comes out of 4.4 is the factoring theorem. And the factoring theorem states that if given a set factor, x minus a, and we solve it and plug it in or do synthetic division, that f of a, if it equals 0, then x minus a is a factor. So if x minus a is a factor, then f of a, when we plug it in or evaluate it for that given value, and it equals 0, it means it's a factor. It also means that whatever that value of a is a solution. So if we divide, use synthetic division or long division, and the remainder is 0, then it's a solution. That's the whole kind of goal with the factor theorem. Or mainly stating that it is, well, actually, that's the remainder theorem. It's mainly saying if we plug it in and get a remainder of 0, then x minus a is a factor, and we could factor it out. And that's really the main thing, or one of the main things that comes out of 4.4. Now, 4.5 is the start of solving. 4.5 and 4.6 is solving these higher degree polynomial functions. Now, up to this point, we've had 4 ways to solve polynomial functions, and mainly revolving around quadratics. The first one is factoring. We went over factoring quadratics in chapter 3, being having multiple sets of parentheses. And if we have 2 or more things multiplied together to equal 0, one of them must be 0. The second way we had was graphing. With graphing, we're looking for what values of x make the equation equal 0. And we can use those to determine the solutions, or really it tells us those are the solutions. And the last 2 ways that we had was the quadratic formula and completing the square. But the quadratic formula and the completing the squares really only works with quadratics. It can work with some 4th degrees, but it gets a little confusing doing those there. But with most of all these methods, we've only done them with quadratics, degree 2 polynomial functions. And that's fine, because if we can find solutions or find values of x that work and decrease the power, decrease the degree from whatever it is down to a quadratic, a degree 2, then we can use the methods that we've had so far to solve. And that's the main goal with most of this here, is to decrease it from whatever its degree down to a degree 2 and solve from there. Now, if we look at these first few here, our first one is our 2x cubed minus 12x squared plus 18x is equal to 0, and we're wanting to solve this here. Now, the first way we're going to go about solving is we're going to do these first 2 by factoring. Now, if we're doing anything by factoring, well, what we should always look for first is a greatest common factor. Because up to this point, even with 4.4, we've not gone over how to factor a cubic, a degree 3, especially if we have a quadratic and linear term. But if we look at all three terms here, 2x cubed, 12x squared, and 18x, is there a common factor between these three here? 2. Is there anything else? Because 2 is in common with our 2, 12 and 18, yes? But we also have x cubed, x squared, and? Because we have a 2 and an x. Because if we factor the 2 out of 2, well, that reduces completely. And if I take one x away from x cubed, we're left with x squared minus. If we factor 2 out of 12, 12 divided by 2 is 6. And if we take one x away from x squared, we're left with x plus 18 divided by 2 is indeed 9. And if we take one x away from x, it simplifies out. So at the start of this, 2x cubed minus 12x squared plus 18x equals 0. Well, greatest common factor, pulling out that 2x, reduced it to x squared minus 6x plus 9. Well, x squared minus 6x plus 9, we can factor those. We've done those. We did that in chapter 3. So there's a good chance we can factor this quadratic here, as long as it is indeed factorable. Questions on this so far? Now, if we do want to check to make sure it's factorable, there is a kind of shortcut that we can do to check that. And that's using this here, square root of b squared minus 4ac. Now this should be somewhat familiar because this is part of the quadratic formula, because the quadratic formula is our negative b plus or minus the square root of b squared minus 4ac all over 2a. Now if this here is a whole number, a non-decimal number, so 0, 1, 2, 3, one of our counting numbers, then we know it's factorable. Because it's going to mean whatever we get out of the overall equation is going to be some rational number. Because if they give us a rational number, then it is factorable. But if the square root of our b squared minus 4ac is a decimal number, or it doesn't reduce completely, we're left with a radical, or whatever's inside of there is negative, we end up getting imaginary numbers, then it's not. And we could check it with this here, because our a, in this case, is 1, b is negative 6, and c is 9. So what we can say is second square root, negative 6 squared minus 4 times 1 times 9. Now, if you remember back from our chapter when we used quadratic formula, we normally didn't type the whole thing in, because there's a chance that what's inside this radical could be negative, and if it's negative, the 30xs will not find it. But in this case here, the square root of b squared minus 4ac is 0. Now, the reason we can do this all at once for this here, not before, is because this here, we're not using it to find the value of x. We're just checking to see if it is factorable, if we can actually factor it. Now, if whatever the number, b squared minus 4ac, what's inside this radical was negative and it threw it out, said it didn't work, that automatically tells us that it's not factorable. Because if it doesn't work, it means it's negative imaginary solutions. So we couldn't be able to factor it anyways. And if it gave us a radical, it means most likely our two answers are going to be irrational. We'll have a square root as part of our answer. So we couldn't factor it there anyways. But because we did get 0, we got a natural number, or, well, a whole number. It means it's factorable. So we can do our two sets of parentheses with 3 spaces. At this point here, we're going to find the sign. To find the sign, we look at the third term. If the third term is positive, our signs are the same and match the sign of the middle term. Since it is positive, they're going to be the same. Match our middle term sign, which is negative, so negative and negative. Factors of x squared are x and x. Factors of 9. 1 and 9 and 3 and 3. Which one do we want to try first? 1 and 9. And if we check this here, x times negative 9 is negative 9x. Negative 1 times x is negative x, giving us negative 10x. All right. We can try 3 and 3. X times negative 3 is negative 3x. Negative 3 times x is negative 3x, giving us negative 6x, which is the middle term we wanted, yes? Okay. So we have it factored completely. Now, this is helpful because at the start, trying to solve 2x cubed minus 12x squared plus 18x, we had no real way to do that. We had no real inclination at this point to find any values. But factoring the 2x out gave us 2x times x squared minus 6x plus 9. We do know how to factor that, which is able to get us here. Now at this point here, we do have 2 or more things multiplied together to equal 0, so one of them must be 0, because that's the only way we can get 0. So we're either saying that 2x is 0, x minus 3 is 0, or x minus 3 is 0. Because if 2x is 0, the whole thing becomes 0. If our first x minus 3, if we plug a value for x in and get 0, then the whole thing becomes 0. And the same thing is true with our other x minus 3. Now at this point here, we just need to solve for the value of x. 2 times x equals 0. Well, we can divide both sides by 2, telling us x is 0. X minus 3. First thing we can do in solving for x is 2. Add 3 to both sides, telling us x is 3. Lastly, with our last one, x minus 3 equals 0, we would add 3 to both sides, telling us x is equal to 3. So our solutions for this here is that x is equal to 0, x is equal to 3, or x is equal to 3. Questions on this here? Now, if we wanted to check these, we could do that by just evaluating it at these 3 spots. So in the calculator, we can do 2 times 0 to the third minus, what is it, 12 times 0 squared plus 18 times 0, which does indeed give us 0. And then we can do the same thing with 3. And it also gives us 0. Because again, we're trying to find out what value of x will make this function be 0. Questions on this here? We're going to look at one more with solving, and then we're going to move on to graphing. 5x cubed minus 40x squared plus 80x. Is there a greatest common factor between these 3 terms? 5, yes. And an x. 5 and an x. Now it's going to be a single x because the smallest variable that we have is x to the first. If x squared had been the smallest power, then we would have taken out 2. But here, x is the smallest one, so we can only factor out 1. And if we factor 5x out of 5x cubed, the 5 simplifies out, and x cubed becomes x squared. If we factor 5 out of 40, 40 divided by 5 is 8. And if we remove 1x from x squared, we're left with x. Plus 80 divided by 5 is 16. And the x factors out completely. Questions on how we got to this point here? At this point here, we need to see if we can factor x squared minus 8x plus 16. And this is factorable. One way that we know that there's a chance we need to factor or solve or simplify down further is if the degree is greater than 1. If the degree is 1, it's pretty much in simplest form. We can start solving. But the x squared minus 8x plus 16 is factorable. We do need to factor it. And the first thing we can look at with this quadratic is our signs. Since the third term is positive, our signs are the same and match the sign of the middle term. So we would have negative and negative. Now we're going to look at the factors of the first and third terms. Factors of x squared are x and x. Factors of 16. 2 and 8, 4 and 4. Which one do we want to try first? 4 and 4. And we can check this here to make sure we do have the correct middle term. X times negative 4 is negative 4x. Negative 4 times x is negative 4x, giving us negative 8x. Is that the middle term we wanted? Yes. And at this point here, we do have two or more things multiplied together equals 0, yes? One of them is 5x. So 5x equals 0. X minus 4 is 0. And x minus 4 is 0, yes? Now again, the zero product property stated two or more things multiplied together equals 0, so one of them must be 0, yes? Our first one's what? 5x. 5 times x, yes? I mean, we could divide both sides by 5, telling us x is 0, but 5 times x is two things multiplied together to equal 0, so one of them must be because we're saying 5 times x is 0. Well, I can't change 5. We can't put a value in for 5. So that means the x has to be 0. If we divided both sides by 5, we would have gotten to the same point. Also, x minus 4 equals 0. We can add 4 to both sides, telling us x is equal to 4. Here we can add 4 to both sides, telling us x is equal to 4. Any questions on any of this here? Finding the zeros of a polynomial function. So we want to find all the zeros of f of x equals negative 2x to the fourth plus 16x squared minus 32. Now there are ways to solve this here. Some of them, one method is called u substitution, but we'll look at it at a later time. Now sketching the graph might help us with this here. Now to sketch the graph, we're going to use the graphing calculator. So to get to our graph, we're going to hit y equals. On the graphing calculator, we'll turn it on, hit y equals. And we're going to type this in. So negative 2 x to the fourth plus 16x squared minus 32. Well, I mean, probably be helpful if I don't type the whole thing in the exponent. Once you get the whole thing in, type or hit graph. Get the whole thing typed in, hit graph. Y equals negative 2. The button above the division sign, well, x and then the button above is the division sign. Oh. 4. And then we'll arrow over, yep. You're welcome. Is everybody able to get it typed in? Yes. You need a calculator?
Yeah, I don't need a calculator. Well, I didn't take one until now. I appreciate it.
You're welcome. Negative 2x to the 4th plus 16x squared minus 32.
I still think that's so cool.
So we look at this here. Now with graphing, we're trying to see what values of x will make the y value be 0. So if we go second graph, we do see 2 locations where it is indeed 0. Yes? One of them is at negative 2, and the other is at 2. Yeah. Now, those are 2 of our solutions. One way we can check to make sure it is a solution is with synthetic division. Because if the remainder is 0, then it is a solution. It doesn't matter which one we use first. And this is also a way for us to check and make sure we do have all the solutions. Because the first thing we're going to do is negative 2 times negative 2 is positive 4. 0 plus 4 is 4. Negative 2 times 4 is negative 8.
Oh, wait, me. Wait. 2 times. So wait, do we put the 4 straight with the 0? Or do we put
Yep.
Oh, we dropped that 2. I forgot.
So we bring down the negative 2.
Yeah.
Negative 2 times negative 2 would give us 4. 0 plus 4 is 4. Negative 2 times 4 is negative 8. 16 plus negative 8 is 8. Negative 2 times 8 is negative 16. 0 plus negative 16 is negative 16. Our negative 2 times negative 16, negative and negative, make a positive 32. And negative 32 plus 32 is 0. 30. Now, since the remainder is 0, it's telling us that this is indeed a solution. Well, we did have another value. We also had positive 2. Because negative 2 worked, now we're also going to try 2. 2 times negative 2 is 4 plus negative 4 is 0. Okay. 2 times 0 is 8 plus 0. 2 times 8. Which does give us 0. Questions on this so far? Because what we started this problem out with is the equation negative 2x to the fourth plus 16x squared minus 32. And we graphed this. And we saw that x was 0 at negative 2 and 2. Now when we did synthetic division twice, we get this here. Now if we plug the variables back in, let's see what equation we have. Our last one was the remainder. 8 is our constant term, our term without x. 0 is our term with x. And negative 2 is our term with x squared. Plus 8. So we're trying to see originally what negative 2x to the fourth plus 16x squared minus 32, what value of x would make it 0. And by graphing, we found two of them. Doing synthetic division, it took it from a degree 4 down to a degree 2.
No, I don't know what long division is.
Now, we didn't have a whole lot of ways to solve this here or find the solutions, but our negative 2x squared plus 8x equals 0, we have gone over how to do these here. Because there's no middle term, we can use the square root formula. Our square root method just states that we get x squared by itself and then take the square root of both sides. Because if there's no middle term, the first thing we can do is get x squared by itself. And we can do that by minusing 8 from both sides, which will tell us that negative 2x squared is equal to negative 8. Now we still have the negative 2, so we can divide both sides by negative 2. Negative 2x squared divided by negative 2, just x squared. Negative 8 divided by negative 2, positive 4. And at this point here we can take the square root of both sides. Square root of x squared is x plus or minus square root of 4. So our other two solutions are positive or negative 2. So x is equal to negative 2, x is equal to negative 2, x is equal to 2, and x is equal to 2. So each one of those ended up repeating twice.
So wait, so we can just.
Yeah, some of these will show up on the test, yes. But that also means, if I go back here, erase this for now. Erase it. Now, you don't have to rewrite this, but we said negative 2 was the solution twice, yes? So if I tried negative 2 here, negative 2 times negative 2 would have given me 4. 4 plus 4 is, negative 2 times 8 is negative 16. 8 plus negative 16 is negative 8. Negative 2 times negative 8 is, which would also given us 0. If I wanted to at this point use 2, bring down the negative 2. 2 times negative 2 is negative 4. 8 plus negative 4 is 4. 2 times 4 is 8, which does indeed give me.
So wait. So what if we get to the graph? The graph would be what x plus or minus that.
Now, we can, because if we look at the graph, does the graph cross at negative 2 or 2?
No, it goes to.
It touches the graph and goes back down. We stated this in chapter 3 because if it touches the graph but does not cross it, it has an even multiplicity. The number of zeros at that point show up an even number of times. Here, at negative 2, we saw that we had how many zeros at that spot? We have 1, 2 of them. So it's an even multiplicity of 2. Same thing with positive 2. If we notice that with the graph, we could have tried it twice and seen if it does indeed work twice, and it did. Did the same, then did 2, which got us here. This is our remainder. 4 is our constant term. Negative 2 is our term with x. So it's really saying that we have 2x plus 4 is equal to 0. So I can subtract 4 minus 2x is equal to negative 4. Divide by negative 2. It tells us x is equal to 2. So it told us that our solutions for the last one were negative 2, negative 2, 2, and 2. Let's look at this one here. X to the 4th minus 18x squared plus 81. So x to the 4th minus 18x squared plus 81. Go on and type that in, and when you get it typed in, hit graph. We good? Yes. So y equals. Because we have positive negative 3, and there's a good chance that it's going to repeat twice at both spots. Because when x is negative 3, the y value is 0. When x is 3, the y value is 0. So there's a good chance that x is equal, well, we do know x is equal to 3 and x is equal to negative 3, but we could have a repeated 0 at those spots. And most likely we will. And the way we can check that is with long division, or not long division, synthetic division. 3, numbers going across the top would be 1 for x to the 4th. I didn't say it on the last one, but because we don't have an x cubed, 0 takes its place. Then negative 18 for x squared, 0 for x, and 81. First thing we'll do is bring down the 1. Our 3 times 1 is 3. 0 plus 3 is 0 plus. Yep. 3 times 3 is 9. Negative 18 plus 9 is 3 times negative 9, negative 27. 0 plus negative 27. Negative 27 times 3 is negative 81. And 81 plus negative 81 is 0. Is that what we expected to get for the remainder? Yeah. because since it told us it was a solution, its value of x made the y value be 0. The remainder should also be 0. Now, he said there's a good chance that 3 could be repeated twice, yes? Why don't we try 3 again? Because if it is 0, we know that it is a solution twice. 3 times 1 is? 3 plus 3 is? 3 times 6? 18. Negative 9 plus 18 is? 9. 3 times 9? And negative 27 plus 27 is? 0. Now, part of the reason we knew 3 was repeated was because it touched the x-axis at that point and did not cross. So 3 showed up twice. Well, the other value of x that we know worked was what? So we can use it. Negative 3 times 1 is? 6 plus negative 3 is? Negative 3 times 3 is? And we get 0. Now, if we get down to 2 terms, I'm going to go and put the variables back in and we can solve from there. Because every time we do a division, either synthetic or long division, we do decrease the degree by 1. The degree of what we started with was a degree 4. So if we did the first division, it takes it down from 4 to 3. If you do it again, it's now degree quadratic. And if we do it our last time, now we're at a degree 1. These kind of equations are ones we like, because our remainder constant term with x is telling us what we have left is x plus 3. These are nice to solve, because we said x plus 3 equals 0. All we need to do is telling us x is. So that means we had negative 3 twice also. And now that we have it all the way solved, we're done because we found every solution. The negative 3 and 3 reduced it down to degree 1. Those are 3 of the solutions, leaving us with x plus 3.
So wait, can we put x? Can we put that like we did? Put x plus minus 3?
So we can say x equals plus or minus 3 and plus or minus 3. Because how many times did positive 3 work? How many times? So it worked twice. And negative 3 worked how many times? So we have positive twice and negative twice.
Why didn't we do that?
Because on the other one, we were only talking about the fact that when we solved it, we got it twice down there. But we also had it listed because it worked twice in both cases.
So we have to put twice on all of them.
Yeah.
There's one here, so
Well, we did it once at the end. We also had to include it the original 2 times we found it on the graph. Here, positive and negative 3 work twice. So that's plus and minus. Or we could just say x is equal to 3, 3, negative 3, and negative 3. We can put commas between them to show that it equaled more than one value. Questions on this here? Okay. 4x to the 4th minus 40x squared plus 36. 4x to the 4th minus 40, not that, x squared plus 36. Type it in and hit graph. How many times does it cross the x-axis? 4. And our values are -1, 1, and 3. Because again, we're looking for what value of x makes the y value be 0. So we have these here. Now we'll pick this up tomorrow.